Morning guys. Okay, so I just wanted to take you through my vacuum pump system for maple sap. This is a pretty straightforward system. Um, I'm showing you it here in the morning before it's actually running, just to give you an idea of what the off sort of position looks like. And then I'll show you it later in the afternoon when it's running. It's probably going to be a good day of running today. It's supposed to be about +3 and sunny all day. So what I'm using basically is a diaphragm pump, and that's what's actually creating the vacuum on the whole system. So this is a 4048 by SureFlow by Pentair. Um, so what this does is I've got, if you look up in the, that's the sugar bush up there. And this is an approximately 300-foot, 3/4 inch line that goes up to that maple tree right there, and it's hooked onto there. And I have 5 3/16 runs coming into that. It's all teed in with airtight connectors, that type of thing. And there's 150 taps in total feeding this 3/4 inch line. So it's on a hill. It's quite a considerable grade. I mean, there's about a 40 foot height difference between where the 3/16 lines come in and where they start up at the top. But anyway, they come into there, they come down this 3/4 inch line, and then they switch over into this 3/4 inch braided line and comes into the pump. So the pump has this little screen pre-filter on it here, and the orientation of this is actually fairly important. I've got it up so that at night when the pump shuts off, and I'll get a little bit more into detail on this as the video progresses and we talk about temperatures for on and off and that type of thing. It basically drains itself, so you don't have any freeze issues. This pump, because it's a diaphragm pump, it can actually freeze. However, the way I've got it set up, there's usually no liquid in this thing to freeze at nighttime. So that's that. I guess we'll start with how this is powered and sort of go through the system in that way. I think that might be the most logical. Okay, so everything starts here at the solar panel. This is a 100 watt, just happens to be a Renogy solar panel. So I'm in Canada. I got a lot of parts from in Canada. So if you're in Canada as well, I mean, all these parts should be available online. So this is a Renogy 100 watt solar panel. 2 wires coming out the back here, positive, negative, go over to this battery box that I made. Now, I made this battery box a long time before I ever decided to set up this vacuum pump system. So one way you can look at it is this is the power solar unit and this is the actual vacuum unit. They're two separate things. Really the only thing connecting this to this is a 12 volt power cord. So if you had some source of 12 volt power all the time, or you have your own thing, like you have your own little battery generator or generator, you could do without this and just run this box and pump system with the thermostat off of a 12 volt source. But if you're in a remote area like me, away from AC power or constant DC power without solar, then you're going to need something like this. You can actually buy these whole systems. I'm trying to think of the name right now. There's different companies that make them. There's like Goal Zero. You can buy, they're about $1,500 for the amp hours that you're going to require to run this. But you can make this one with just basically a deep cycle battery and a solar charge controller. If you look into this box, there's a ton of extra stuff I have in here because this is actually, it's got an inverter in here. It's got a battery monitor right here, but really all you would need for this setup is the solar charge controller right here and the solar panel. But I'm going to explain how this one works right now, the way I've got it set up. So like I said, the solar panel feeds this box. So the solar panel comes in here, and all these are just connectors so they can be on the outside of the box. But okay, so the solar panel wires come in and they go all the way over here and they go directly into the solar panel side of this Renogy Wanderer solar charge controller. This is the RS232. It's very affordable, works very well. So the solar panel wires go into here, as you can see, positive, negative. And what this box does basically is it just monitors the charge level of your battery. So it doesn't overcharge, charges it when it's necessary. You can even go through the select button there and you can see your battery voltage. You can see how much the solar panel is providing, how much the battery is drawing. Basically, it does everything you need to do to run this system or any other 12 volt system. So from there, this is the 2 battery terminals. So if you were doing this without any further controls or monitors, you would just wire that directly into your battery. So I just happen to have what do I have here? It's a Nautilus, which is like a Canadian Tire brand battery. And so it's a Group 27 battery, 92 amp hours, 900 cold cranking amps, and 175 reserve capacity. But I mean, you just need basically a deep cycle marine battery or, you know, car battery type thing would be fine. So you could go directly into your battery from these terminals, and then you could run, so this box I was telling you about, you could run that directly off of these. This little light bulb, this would be your load. So you could go right from these 2 wires right into your pump, thermostat and pump. However, in my system, I have one more thing in line. So it comes out of the battery terminals here, and the negative goes to the negative terminal of this device here. And all this is a measuring device, and it's connected to the negatives. This is just goes directly to the negative side of the battery. All my negative wires go to this terminal here, and then this wire goes to this controller or monitor, I guess, on the front here. So this tells me battery percentage. So I'm at 80.4. You can go how many amp hours. So this is how many amps I'm using right now, and that's just because the thermostat is running. When it's charging, so it's pretty early in the morning, there's not that much sun, but when it's charging, you'll see a plus right here or a minus, depending on if the system is taking or giving power to the battery. So it's just a nicer way. It's out. I put it here because it's out on the front of the box, and it's nice to use. The only thing you have to set on it is the amp hour of your battery when you start. So whatever battery you end up buying, and if you want to use this, then you have to just set up the amp hours. I got this on Amazon. That yellow wire there coming out of the bottom, that's just positive power for that little system. That's all that is. And then, so the battery wire comes out here and goes to the positive of my battery, super simple. And then, so to power this, I have it plugged into right here. And this literally just takes power from the positive side of the battery. From this wire, it's connected to the positive side of the battery. And this negative wire is connected to the negative terminal of my meter, which might as well be connected to the negative terminal of my battery. These are one and the same when you're talking about adding or taking power from your battery. So from there, we leave this power box and we head into the actual vacuum pump system. Now this looks complicated, but it is so simple. It's super simple. So what I have here is I have an Inkbird. This is just the one I basically decided to use. I got it on Amazon, super affordable. I think it was about $50. Could be wrong on that. But you'll see it flashing there, I think, on your screen. But basically the temperature right now is negative 4.8 degrees C. And I've got the probe right here. The probe just comes out of the side of the box. And this is in a location where it doesn't see sun at any point during the day. So it gets a true reading of the air temperature. Which you're gonna want a good accurate reading, because that thing's black. If the sun was shining on it, you would get a totally different reading. So all this does is monitor the air temperature, and then it's got basically leads on it. You can use this for heating and cooling systems, but we're basically using it effectively as the cooling system, because when the temperature rises, we want the pump to come on, and when the temperature drops, we want the pump to shut off. So think of this as like an air conditioner. So, I mean, it gives you all the wiring diagram in the manual, but right on the back here, you can see, so you've got your power supply, which is your 12 volts coming from your power box. So you plug those in the bottom. Your sensor, obviously, there's your two sensor wires, 3, 4. And then 5 and 6 you're not going to use. 7 and 8 are your cooling. So it's basically the power for your cooling system, which in our case is the pump. So for me, and what you can do is this thing is actually rated to 10 amps. The pump says 15 amps, but it never actually draws that much in this type of a system. So you could directly connect this thermostat to this pump and I think it would work fine. However, I just, to be safe, I put in this automotive relay. These are super simple. You can literally buy them anywhere online. Any electronics store should have them. They're a very common thing. So to wire this, basically what this does is it uses a little bit of power to activate a switch inside that allows you to turn on and off high amperage devices like pumps and lights. So you can see right on here 30 or 40 amps. So it does two things. You can have it in the normally, trying to get it to focus there. You can have it in the normally on position, which would be if you had the positive connected to 87A, but you want it connected to 87 so that when this gets energized, the pump comes on. So basically you're going to connect ground to 85. You're going to connect your power to, well, you're going to connect your power coming out of your thermostat to 86. And so when the thermostat switches on, it'll energize 86, which will then flip this switch right here over to 87, and 30 is your incoming 12 volt voltage, and 87 is where your motor is connected. So from that, so the yellow wire is actually the power for your motor. The way I have it set up is, so we'll go through it here. So my set temperature, just hold down set. So TS is your set temperature, and we'll click set again. I've got it set to negative 1.5 degrees Celsius. So I have this pump shutting off at night at negative 1.5 degrees Celsius, and obviously that's below freezing, and I found that that's the best way to keep the pump from freezing up. And the reason is, basically what happens is once it drops below 0, the liquid in the lines begins to freeze. And because it's beginning to freeze, any liquid that's just left in this section right here, because the pump is still running, gets sucked out of here, and basically this starts pumping air because it can't suck anymore because this stuff is beginning to freeze. And I found that at about negative 1.5 degrees Celsius, it's the perfect sort of temperature range where this totally runs dry and then the pump shuts off, which is what you want. And then if we go back here, hold down set, we'll go to difference in temperature, DS, set. I've got it set to 3 degrees Celsius. So it's a 3 degrees Celsius difference. So the pump kicks on at 1.5 degrees Celsius in the morning when the air temperature on that probe heats up to 1.5 degrees Celsius. So the way sort of that works is between 0 and 1.5 degrees Celsius, this line is thawing out, the trees are thawing out, the 3/16 lines are thawing out, this area here is thawing out, and basically this becomes liquid sap, and then at 1.5 degrees Celsius the pump kicks on. So the pump isn't running unnecessarily when the lines are frozen. You could maybe turn that up to maybe 2 degrees Celsius because there is sometimes slush I find in the lines. So you can play around with that, and it totally depends on the location you're in. If your sugar bush is heating up sooner or later, depending on how much sun it gets, that type of thing, you got to play around with it. But that's sort of the theory to keep your pump from, and filter mostly, from freezing up. The pump can freeze, but it's not nice when this freezes up here. It gets all, it can break this. But I haven't had any issues with that after, adjusting my system. So basically, that's about it for now. It's a super simple system. If you don't have any 3/4 line coming to yours, you can connect this directly to your 3/16 lines. It's basically, this is a great pump for smaller systems, and I would say even up to like about 500 taps you could run off of this system, no problem. because I've got mine connected to a 3/4 line, which I haven't seen a lot of guys do before the pump, it's not always pumping sap, if that makes sense. So basically with mine, what happens is every about 10 minutes, you get a big surge of sap coming through the system, but it is always keeping a vacuum on the system, which is really what you're looking for. So you'll see when it's running today, but basically there's always bubbles being pulled through this line, and that's the air being pulled through the system and keeping vacuum on the lines up in the trees and on this line here. And then it gets to a point where this 3/4 inch line fills up with sap so much that it starts coming up the tube, and then when it hits the pump, it actually, because it's getting really good suction, it starts pulling all the sap that's been in this line in the bag there up in the lines, and just like basically you get like almost like a 5-gallon surge of sap every 10-15 minutes with this system. If you had it directly connected to your 3/16 lines, like a lot of guys I've seen do, you have pretty much a constant flow of sap running through the pump. So that's really the only difference with using the 3/4 I've found. So that's it for now, guys. What do we got for temperature here? -4.2. So it'll be a while before this kicks on, but I'll come back later and hopefully I can show you this thing in action. Hey guys, okay, so pretty warm out right now. It's about 1 o'clock in the afternoon, and we've got 7.3 degrees Celsius, 7.2 at the thermometer there, and the sap is flowing. It's not actually, the pump isn't pumping liquid sap right now. Let me just open this up. As you can see, it's not pumping liquid sap right now, but what this system does basically is it builds up, so it's always pulling vacuum. Hopefully you can see that bubble there. So you can see that bubble always just bubbling through the line. So it is always keeping a vacuum on the main line and all the 3/16 lines up in the forest. And then I would say every about 10 to 15 minutes, I get about a 4 to 5 gallon dump of sap coming through. I don't know, it basically just builds up, and then it goes into the pump, and then it sucks out whatever I think is in this line, plus a whole bunch up in the lines in the forest there. So that's how this works when you're not directly connected to the 3/16. Just want to go through some power consumption items. Well, I got my meter down here. So this thing's actually pretty accurate. So let me unplug the panel. So I unplugged the solar panel. So we're drawing 1.42-ish amps. And I'm just going to confirm that on my meter here. So this meter is connected directly to the outgoing power to the pump, and it's showing 1.46 on this. I trust this one more than I trust that little one there, but very close. So let's say 1.4 amps, which is like nothing. So that's why the panel is able to stay ahead of it. And then when I plug the panel in, you'll see this go from negative to positive. So we're positive 2 amps, 2.2-ish amps. So we got a fairly sunny day, like it's, you know, a little bit of cloud cover, but this panel is doing a great job at keeping, or actually charging this battery. So yeah, right at 2 amps there. And that's 2 amps going into the battery. So let's see how much the panel is actually producing. So panel's producing, yeah, 3.4 amps. Let me just make sure that was zeroed out. Yeah, 3.5 amps on the panels today, which is really good. Oh, okay, here we go, guys. We got some flow happening here. So it just started. So that's a 5/8 poly hose. See how many amps are drawing when there's fluid going through. So we're pulling fluid through, and 2.5, 2.7, 3 amps when there's actual liquid flowing through. So you can see that the liquid is flowing. Try to do it in one clip so you can see. So we still got flow happening here, and we're pulling 2 and then it jumps up. Sometimes when it gets a really big flow with no air, it goes up to 3. But yeah, so not even when it's got full liquid going through it, really I just saw a spike of like about 3 amps there, so not too bad at all. And we're done for that little amount. So now you can see the bubbles are still going through, but we have no liquid. We're just building up that vacuum again. Hey guys, okay, so we got 15 taps on this length of 3/16 line so far. Probably add another 15 or so onto it going up through there. But with the 15 taps, I'm just going to cut this. I'm going to show you, you can actually hear the vacuum coming off of this. So we've got the 4048 Pro or SureFlow pump on it down at the tank. And so we've got some natural vacuum because we're on a hill, and we've got the suction from the pump. So I'll let you hear the suction coming out of this when I open up this line. So I got the tap put in there. Keep in mind the end of this line is actually plugged. It's got an end of line hook plug on it. So I'll show you the suction, hope you can hear it. So yeah, hopefully that was a good walkthrough of the system for you guys. If you want to build it, very simple, like I said. If you got any questions about it, just leave them in the comments and I'll try my best to answer them. Thank you for watching.